Welcome back, ladies and gentlemen. This is Dr. Robinson again, and we're going to continue our studies. This time we are talking about the axis of symmetry. So we have a nice picture here, and I see vertex turning point down there, and x equal -2, and a little computer movie that we'll be showing in class. So let's get started. The axis of symmetry is the line that passes through the vertex, and vertex we were just mentioning is the turning point. It's parallel to the y-axis. It divides the parabola, that was that U-shaped curve, into mirror images. So it's going to make a mirror image of it. So it's going to divide it into two parts. So the axis of symmetry is an equation of a line, not just the number. So you do get x equal or the number that we're talking about, but it's really an equation. So you should check out our video on equations of lines or linear equations just to see what we're talking about there. Here's some other words and terms you should know. Standard form of a quadratic equation. You should always have it set for y equal to ax squared plus bx plus c, where a, b, and c are very important to the quadratic equation because the formulas are based on those letters. So here's one formula that we're going to study on today, and that's the formula for finding the axis of symmetry, where we're going to be solving the equation for x equal to -b over 2a. That's the formula we're going to use today. So later on, you'll get into what's called the quadratic formula, which part of this axis of symmetry formula comes from. So the quadratic formula is -b plus or minus 2 square root of b squared minus 4ac. That's divided by 2a. So that's good to know. Hopefully you'll see some more videos on that. If I get time, I'll cook up a video on that so you can deal with the quadratic formula and all the other things that go with it. All right, so first question, find the axis of symmetry for f of x equal to x squared plus 4x plus 3. All right, so the first thing we need to do is identify the a, b, c terms of this equation. So it's already in standard form because we know f of x is really equal to y, so it's already there. So all we need to do is now identify the coefficient of x squared term, that'll be the a. So there's no number there, and we know if there's no number there, it's a number 1 that's placeholding. The b is the positive 4 plus 4. The c would be the plus 3. So those are the three terms. So as I said, our a, there's nothing there, so that'd be 1. Our b is the plus 4, and our c is the plus 3. All right, let's write our formula that we need, which is the axis of symmetry formula, because we're going to do some substitution there into that formula, where x is equal to -b divided by 2a. Now, you can say -b or just the opposite of b, because b is plus b, just say the opposite. So if b is plus, the opposite of b would be minus. If b is minus, the opposite of b would be positive. So that's a good way to look at it. So we're going to substitute in place of those letters, um, uh, b and a. I'm just putting in parentheses so that way I can do my substitution so you can see where it really comes from. So I know b is equal to 4, so I'm going to put in place of this b 4 and in place of a 1. So I don't need the c in this case, but it's good to have because you're going to need it later. So I substituted 4 and 1, so I have negative times 4, the opposite of positive 4 is -4, and 2 times 1 is 2. -4 divided by 2 is -2. So my equation of the line is going to be x is equal to -2. So that's basically how you find the axis of symmetry. When you graph it, let's go back, you'll be drawing a line on the x equaling -2. And I don't know if this was the function, but here you have some type of parabola, and the x is a vertical line that goes straight up and down, and it goes through the point uh, x equaling to -2. So check out my video on graphing those vertical and horizontal lines. So let's go back and let's see. So x was equal to -2. So that was good to see. So we saw the graph of that as well. All right, so I have a question for you. So see if you can get it. Remember, pick your ABC and use your formula. Hopefully you'll be able to get it. Check your understanding. If you understand what's going on, great. If you're not sure, rewatch the video, see what I plugged in, and try it yourself. Here's another question. Choose A, B, C, or D. The equation for the axis of symmetry for f of x equal x squared minus 4 is, so choose your A, B, and C. I notice there is no third term there, so that's interesting. So remember, uh, it's equation. I know you turn to think of solve it for a number, but it's an equation, and it's always x equal. So I notice they have y equal, so I'm going to automatically eliminate choice C and D. So hopefully you'll figure out by substituting and getting the correct answer. So it's either A or B. So do the substitution. What else we have? Here's another one. Find the axis of symmetry. F of x equal negative x squared minus 2x plus 3. So here we got a negative x there, so keep that in mind. So remember the coefficient for A, and here's our B, and there's our C. So substitute. Let's see what you come up with for that equation. So I hope you enjoyed the video. I hope it was easy for you. And if you have questions, write them down, bring them into the class the next day, and we'll talk about them. So if you want to see more tutorial videos, watch me on YouTube. My channel name is Dan Robinson. We have other nice videos that you'll enjoy. We have PKMS Math Prep 19, which is our latest release that we made this year, and I hope you'll check it out. Give us a thumbs up, subscribe to my channel so you can let me know how we're doing, and give us a thumbs up and write a comment. Let me know what I can do to improve the videos, what I'm doing right or what I'm doing wrong. You can tweet me at drobmath1 as well. Don't forget to check out our show Math Time on Tuesdays from 4:30 p.m. to 5 p.m. on Optimum Cablevision Channel 15. And I hope you enjoyed the video, and I hope you got something out of it. This is Dr. Robinson, and I'm signing off. Bye-bye.